Wow, thank you very much. So this is Shaders 201, and you and I are very lucky because for the next 45 minutes we get to talk about shaders. So the reason it's called Shaders 201 is because last year I gave Shaders 101. So this is like the next step up from that. How many of you were at my talk last year? Wow, and you came back. So this year I tried to pick a couple of examples to go through step by step that are just a little bit more advanced, but hopefully if you're new to shaders, they won't be too far over your head. They'll be something that you can stretch to learn. And I'm really excited to go through these things with you today. So I chose the subtitle, Making Art with Math. This was just kind of an off-the-cuff line that I threw out last year in the middle of my talk, but it really struck me that this is what you're doing when you write a shader. You're doing all this like calculation and math, but what you end up with is something beautiful and something visual. And that's what I really love about shaders. The other thing that I really love about shaders is, as technical artists, there are a lot of things that we do that are just like really thankless jobs. You can write a tool that saves the artist like hours of drudgery, but you only hear about it if something breaks. And he's like, hey, why is this screwed up? You know, I got this error. Or if you're skinning a character or making a rig, you know, it really helps the animator out. It looks beautiful in the game, but if there are a couple of verts out of line, you get bugs and people complain and like, why aren't you doing your job right, you know? But with shaders, you get to work on cool stuff. People walk by your desk. They're like, whoa, that looks amazing. So I don't know. Maybe I'm just maybe I just really like attention. But that's one of the reasons that I love working on shaders. So just as an introduction, these are some of the game projects that I've worked on over the years. I've been at BioWare for coming up on 10 years now. And you can see that Star Wars: The Old Republic on this slide is much larger than any of the other games, and that's because I worked on it for a lot longer than any of the other game projects. If you ask me what I'm working on right now, I'm sorry, I can't tell you. It's super secret, but hopefully we'll have more to say about that soon. It's something that I love, and I'm really excited for everybody to be able to find out what it is, but not yet. So some of the things that I've done over the years, I developed a plugin for 3ds Max a long time ago called Shader Effects, together with Case Reinen. And Shader Effects was oh, thank you, Shader Effects fan. Shader Effects was purchased by Autodesk, and it's now an integral part of both 3ds Max and Maya. It's basically the way that you create real-time shaders in Max and Maya with a node-based interface. I was also the author of a series of DVDs teaching artists how to write shaders in HLSL. Unfortunately, the company that published my DVDs is no longer around, so those aren't available. Sorry about that. So this is what we're going to go over today. I'm going to start out by going over the examples, the example shaders that we went over last year. And I'm going to go through those, just kind of a really quick overview. I know some of you were here last year. Maybe some of you caught my talk on the Vault. So I'm not going to spend a whole lot of time going through those. But I did want to at least touch on them and reintroduce some of the important topics that we learned as we went through those, because I'm going to use those to lead into the examples that we talk about this year. As we go over these examples, you'll notice that I've used the Unreal Engine's node-based shader editor. And the reason I do that is it's really helpful for somebody new who's learning this to see this stuff represented in a node-based workflow. If you are new to writing code and shaders and you just see a big block of code, a lot of people's eyes glaze over and they're just like, there's no way I can learn that. So that's why I'm using the Unreal Node editor. However, at the end of each of the examples that I share, I will put up a slide that has the code. If I were writing the shader in HLSL, this is the way that I would code it. And just to represent the fact that You can create a shader in a node-based editor. You can create a shader in HLSL, and they do exactly the same thing. Now, at work, we use the Frostbite game engine, and I really love Frostbite, but I wanted to work on this talk at home and not have to worry about getting approval for what I could and couldn't show. And so I downloaded the Unreal Engine, and I'd never used it before, but within just a few minutes, I was up and writing shaders the same as I write at work. All right, so let's review. The first shader that we went over last year was distortion shader. And what I'm doing in my distortion shader is I have two textures. Let me see if this fancy virtual mouse thing works. Ooh, look at that. So there's a texture and there's a texture. So I have two textures, and I talked about scrolling UV coordinates. So you can see right here that I'm taking my UV coordinates, and I'm adding, or I'm multiplying value, or that's time actually. So taking time and multiplying a value by it, and then adding that to my texture coordinates. Anytime you add a value to texture coordinates, they scroll. So I'm adding time, so my texture coordinates are scrolling. And you can see for each time block, I'm multiplying a different value. So I've got one texture scrolling at one speed in one direction, and another texture scrolling at another speed in another direction. And the combination of those, last year when I was going through this, I started out just with one scrolling texture, and the problem with that is you start seeing the loop. And so using two textures, scrolling them across each other at different speeds, you can overcome this loopiness and get a pattern that doesn't loop. Now, what I'm showing here in the slide is a video, so obviously it does loop. But if you see this in real time, because of the different patterns, there's no looping. All right, so that was my distortion example. A little bit later in the talk, we're going to revisit this with one of the effects that we go over. The second example that I showed last year is the Atlas walk. Now, an Atlas texture is a series of frames of animation, and they're all packed into a texture in chronological order. So you can see here's an explosion, and it was really nice. This texture just ships with Unreal Engine, so I just took it and used it. But so you can see the explosion is arranged in rows of 6 frames, and the purpose of this shader is to display those frames one at a time. And in the video, you can see it looks like a really smooth looking movie, but that's because the frames are playing back one at a time. So the principle that I taught last year in this example is that we have this idea of a floor node rounds something down to the nearest integer. So if I take time and I multiply it, so time is over here on the right side of the slide. I multiply it by 24 there. You can see that's the frames per second that I want it to go. And then I apply floor. And so time normally just proceeds linearly, but when I apply that floor value, it proceeds in a stair-stepping pattern, and that's how I'm able to jump from one frame to the next instead of scrolling the texture. So I jump from one frame to the next, and then every 6th frame I need to jump down a row. So that's what we're doing in this example. And I'm not going to explain it all, but if you want to go back and watch last year's talk, you can get more details. All right, so for the final example that I showed last year, it was this projection blend. And this is a really neat idea for allowing your artist to not have to create tons of assets. In this example, I'm using the Y world space direction to project a material onto a mesh. And the material can be anything that makes sense in the environment. It can be sand or snow or in this case, it's moss. So normally, if an artist is creating a bunch of mossy rocks and a bunch of snowy rocks and a bunch of sandy rocks, he has to create a ton of these things. But using this shader, you can just create 2 or 3 rocks and rotate them in lots of random directions, and the shader will project the material onto them from the top. So no matter which way you rotate your rock, you're always going to get this stuff on the top of it. So it cuts down on the number of assets you have to create. Really convenient. So in this shader, I went over the concept of converting a normal to tangent space, or transforming it to world space. So there's my B, or my Y coordinate. And so that's projected in the Y direction. Then all these other nodes over here on the right are the math that we're doing to just change up the mask. And then we're using that mask to blend between the rock texture and the moss texture, and then the same with the normal maps, blending between the rock normal map and the moss normal map. So also in this example, I went over the lerp node, which is an easy way to blend between 2 inputs with an alpha. All right, so let's move on to the examples that I'm going to show this year. So the first is cloth shading. And when the people set up this room, they were really generous in creating a beautiful visual aid for me. So what I wanted to talk about with cloth shading is there's a lot of different kinds of cloth, and there are a couple of different properties of cloth that we're going to talk about. The first one, you can see right here, this is cotton, and cotton has a tendency to be brighter on the edges. So when you're looking at edge angles, like right here, because it has these little fibers that are sticking up, those catch the light. So we need to figure out a way of brightening up the cloth on the edges. And kind of an opposite property of that, over here on the other side, we have a highlight that's on the angle that's facing the camera. So cloth like silk or satin is brighter when it's facing you versus the edges. So we need to create a shader that imitates these properties of cloth. So the idea that I'm going to show you is something that was first presented, and I learned it from John Hable's talk when he was talking about cloth shading that he created for the Uncharted games. So here's our friend, the Fresnel term. And on this slide, I've represented Fresnel math in 3 different ways. First, we have the code that can sometimes be scary for people. We're doing a dot product of the normal and the view vector. In the middle, we have a visual representation of what a dot product can do. And then on the far side of the slide on the right, we have the camera vector and the normal vector and a dot product. So what we're doing here is measuring the angle between 2 vectors. So my camera vector is a line between me and the thing that I'm looking at. And my normal is the direction that my model is facing. So if I'm looking right at my model and it's looking right at me, and I compare the angle between those 2 vectors, the dot product will give me a value of 1. So anything that's staring right at the camera will be a value of 1. Anything that's perpendicular will be a value of 0. So the image on this slide is actually opposite that, and I'm going to get to that in a minute. But that's basically what we're doing with the Fresnel term. So in our shader, we're going to start off really simply just by doing a dot product between our camera vector and our normal. And that gives us what you can see over here on the right. So we have something that's white in the middle, and then toward the edge it's kind of black. And this is lit too, so it's not super black, but you can see it gets darker on the edge. Now what we want, as you saw in the previous slide, what we want is actually the inverse of that. And to invert a value between 0 and 1, you just do 1 minus your value, and that flips it around. So there's a good foundational principle to know. Any value between 0 and 1, you want to flip it, you just do 1 minus. So that gives me something that's dark in the middle, and then on the edges, it starts getting brighter. Now, what we really want is to push the brightness further toward the edges. So we need to raise this to power. So I'm going to introduce a POW node, and I'm going to raise it to an exponent. So, whoops, wrong button. So here is my POW node, and I'm raising it to an exponent. Yep. All right, now the next thing we want to do is brighten it up a bit. So we've got the shading pushed toward the edges. So now we're just going to multiply it. So we're just going to multiply it by a value. So now we have two parameters. We have the value that we're raising it to a power of, and then we also have the multiplier value. And I can use these two parameters to control like the fall off of the effect and also the brightness of the effect. So if I were fine-tuning this for cloth, I could adjust this value here and this value here to get just the effect that I want. Now, when we were looking at the initial slide with all the pictures of cloth on it, the other effect that I showed you was the opposite, where things are brighter when they're looking right at you. And so we're going to take the Fresnel term and we're going to double it up. And so we get this. So here I'm doing the brightness on the outside and also the brightness on the inside. And I have 4 values that I can use to control it. So I have my power value of 4 here, my multiplier of 2 here, power value of 4 here, and another multiplier of 2 here. So I get something that looks like this. So now I have a brightness in the middle and a brightness on the edges. And I was doing a dry run with this talk with my wife, and she said, yeah, but that doesn't look like cloth. All right. So we have to add some texture maps. So I went and scanned my jeans. And I created a diffuse map and a normal map. And I was like, okay, I hope this looks a little bit more like cloth. So just for a minute, we're going to set aside our Fresnel stuff here. And I'm just going to plug in my diffuse texture and my normal texture. And you can see over here, I'm multiplying my texture coordinates by 3. And what that does is it just tiles the pattern more. So I get a result that looks like this. Now this is what it looks like before any of the cloth shading. So we need to rewire the cloth shader back in. So that's what we're going to do on the next slide. So I just take the result of my diffuse texture and I multiply it by my Fresnel. And this serves to brighten it on the edge and in the middle and kind of darken it in between those two. And my wife said, yeah, but that still doesn't look like denim. She's hard to please. So what I told her is, no. I'm not actually trying to make denim. I'm just trying to make a shader that can create all kinds of different cloth. And I can give this to an artist, and the artist can tune it. So you can change this value here, this value here, this value here, and this value here to get something that actually looks like what it's supposed to be. And so I went ahead and I made a couple of examples of what this can look like. So on the left, you can see an example of cotton, and it's mostly just using the edges. And then denim, and that's using both, but they're really sort of subtle. And then silk over here is using sort of heavy middle and like kind of light around the edges. So you can do all kinds of different variations of this. Now, I will point out that it's not mathematically, physically correct because it's dependent on the view for these effects as opposed to the light. But it does allow you to very easily create an imitation of what cloth looks like without having to go to a graphics engineer and say, hey, can you rewrite the engine and create a cloth BRDF for me? You can do it yourself, and it's pretty simple. So that's kind of the benefit of it. Okay, now as promised, here is my slide with code on it. And if you don't like code, you can just kind of like, oh no. Avert your eyes, but this is what the cloth shader is doing. So you can see here, I'm doing my dot product between my eye vector and my normal, and then I'm adjusting it with my parameters here. And this is flipping the Fresnel so that I can get the edge, and then the inner version doesn't flip it, you can see. And then I add those two together, and then I would take the result of this function and multiply it by my, my diffuse texture. All right, so that's my cloth example. For the next example, we're going to talk about rain ripples. When I was putting this example together, first thing that I did is I went to YouTube and I found a video of some rain ripples. But then the week that I was building it, it rained, and I was walking through the parking lot at work, and I was like, wow, look, there's rain ripples in this puddles. I can actually put up my own video of rain ripples that I captured myself. So here you have a glimpse of the parking lot at BioWare. What you see here in each of these ripples is that they start really small in the center, and they grow out toward the edge, and they kind of fade off at the edges. And there's not just one ripple in each of them, there's multiple ripples. So this is the effect that we're going to try to imitate. And the technique that I'm using here, I originally learned from Sébastien Lagarde. He has an amazing website where he talks about all kinds of things related to rain and wetness and all these great ideas. And he did research on this stuff when he was working on a game called Remember Me. All right, so we'll start out with a texture that looks like this. It's just a really simple Gaussian radial gradient. And one way to create these ripples would be to use the technique that I talked about last year with the Atlas walk. I could create an animation of a ripple, but that would require a texture that's fairly high resolution because I have to store all these frames. And so it would take a lot more texture memory, and the animation wouldn't be as smooth. So instead of using that technique, we're gonna learn how to do this with math. So the first thing that I want to do is figure out how to make this radial gradient grow from the center and kind of reveal itself. And so what I'm going to do there is I'm going to take time. And in this case, my time node is cycling between 0 and 1. So it goes from 0 to 1 and back to 0 to 1 like that. And I'm going to subtract 1 from it. So now, instead of going 0 to 1, 0 to 1, it's going -1 to 0, -1 to 0, -1 to 0. And then I'm going to add that to my texture. So when I do that, dun, 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 I get my radial gradient growing from the middle. Now, ripples are the next thing that we need to try to do, and what we need to create a ripple is a sine wave. So I have time, or a value that's going linearly, like my gradient, and what I want to do is use a sine wave to create a wave like this instead of a continuous linear value. So if I take my gradient over here on the left, I'm going to multiply it by pi and then pass it through a sine function, and the result that I get is over here on the right. So that's the static result. My sine is creating these nice waves, but now I need to combine it with what I was doing before. So here we go. So this is what I was doing before over here. I multiply it by pi and pass it through my sine function, and what I get is this. So when I showed this slide to my wife, she's like holding her hand up to the computer monitor like, no, no, no. I was like, what, are you getting hypnotized or something? Maybe that's a good thing, like buy BioWare games. Right? All right, but no, that kind of illustrates a point, and that is that the original example that I was showing of the actual rain ripples were fading out at the edges, and this doesn't do that yet, and so we need to do a little bit more math. And so what we're going to do, oh yeah, here's our sine wave. And so what we're going to do is we're going to take time and do 1 minus time right here. And we're also going to take our original gradient texture and multiply it by that. And that gives us the opposite. So instead of growing from the middle, it's going to shrink, right? And then we're going to take our whole thing and multiply it by that. And the result is going to be the ripples that fade out at the edges. So we're just multiplying it by the inverse to get it to darken at the edges and darken as it goes along. Okay, so we've got a pretty nice mask for our ripples, but what we actually want is the shape of a ripple. And so we need to introduce a normal map into the equation here. And so what I'm going to do is I'm going to take the gradient that I was using before, and then I'm going to take a normal map of a cone. So I'm looking straight down on a cone, and I created a normal map from this cone here. And I'm going to take my gradient and put it into the red channel of my texture. And I'm going to take the X and Y of my normal map and put it into the green and blue channels of the texture. Now, I keep bringing up my wife, but she looked at this texture and she's like, whoa, there's crazy rainbow colors. What does that mean? And I was like, no. Don't think about this as a color. It's just data, right? I'm packing the normal map into green and blue and my gradient into red. So I know it looks kind of screwy, but we're going to separate out the data and the shader and use it for the appropriate things. All right, so here we go. So we've got our nice texture over here. And remember the gradient's in the red channel. So here it is coming out of the red channel. And this is all the stuff that I was doing before. So this part is my mask. And then this part down here at the bottom is my normal. So I combine the X component and the Y component of the normal with my append node. And then here I'm multiplying by 2 and subtracting 1. And that is expanding my normal. So normal data is from -1 to 1. But when it's in a texture, it's from 0 to 1. So I have to expand it. So by multiplying by 2 and subtracting 1, it moves it from a range of 0 to 1 to a range of -1 to 1. And then I'm going to take my normal and multiply it by my mask. And then I'm just going to append 1 to it. So this 1 down here becomes the Z component of the normal. If I wanted to, I could go and do a bunch of like square root kind of math to calculate the correct Z component. But in this case, it doesn't really matter. So I can just use a value of 1. And then I plug the normal into the normal socket of my shader here. And I get this. Yeah, ooh. All right, so I've got the actual shape of a nice looking ripple. But the effect that we want is a lot of ripples, not just one. So we need to change our texture. So I'm going to take this texture that I have and kind of clone stamp it all over and use lots of different sizes. And then I'm going to use this in my shader instead. So here's my texture, and it's doing the exact same thing. It's just I swapped out the texture with the pattern repeated a whole bunch of times. And that gives us this. But these are in sync. And we don't want boy bands here, so sorry, that was really bad. So we need to do something else. And so what I'm going to do is introduce one more piece of data. So I'm already using the red, green, and blue channels of my texture, but I haven't used my alpha channel yet. And so here in the alpha channel, I'm going to store, for each of the ripple shapes, I'm going to store a different grayscale value. And this data I can use to offset the time. Okay? So I've got my RGB, which is my gradient, my normal, and now I've got a time offset value in my alpha. So here you can see that coming out of my alpha channel, I've got this wired up here, and I just add that to time. And then I use this frac node, which gives me it gets rid of the integer and just gives me the decimal value. Okay, so now that I've offset these in time, we end up with the final result. Yay! So we've got lots of ripples, and the videos don't loop very well, but you can see this is working pretty well. Now at this point, there are a lot of things that I could do. I could do this whole shader multiple times and overlap the results with different scales and different time offsets. Because in the original example of real ripples that I showed, you could see that the ripples were all overlapping each other, right? And here they're not doing that. So if I wanted to run this shader multiple times and overlap the results, I could get some really convincing ripples. Or what I can do is I can take these normals and I can use the normal result for distortion. So last year I talked about distortion using the two scrolling textures, but in this case, I'm going to use my normal value that's coming out of here, and I'm going to multiply it by a very small value because I need to reduce it. I don't want to distort it a ton, or you wouldn't even be able to recognize my texture at all. But I'm going to take the result of that and add it to my texture coordinates, and I end up with something that looks like this. Yeah, pretty cool. This is fun. All right. Now, as I promised, I also get to show a slide of code. So if you like code, you can enjoy looking at the HLSL. So this function computes a normal that you can then, a ripple normal that's animated that you can then use to do all kinds of fun things with. And there's, down at the bottom of the slide, there's a link to Sebastian Lagarde's really nice blog. All right, are we ready for the last example? So we're going to talk about volumetrics. And so here I have an ice block. And I went and grabbed a 6-pack cooler and filled it with water and stuck it in my fridge for a couple days. And the result was this really beautiful ice. And you can see there's a lot of details on the surface, but there are also a lot of things going on inside the volume. And that is the effect that I want to try to achieve. Now, I got this idea from a guy named Chris Oat. He worked for ATI a very long time ago, and he basically gives this idea of how to do this volumetric effect, which is very similar to offset mapping, but it's like the inverse of it. So let's go over that. So we're going to start off first just by passing our texture coordinates into our texture. And the result of that is, a normal texture stuck to the surface of our model. And there's no parallax movement there at all. It doesn't look like there's anything inside the cube. It's just a solid surface. And what I need to do is figure out how to offset the texture coordinates of my texture so that it looks like the texture is actually inside the volume versus on the surface, all right? And so this is an example of what I have now. I just have my camera moving around, or my object moving around. Here's my surface. The red arrow is the normal on the surface. And what I want to do is this. I want it to look like, instead of it being on the surface, that there's a subsurface, and it's moving as my view moves, right? So there's one thing that's sort of like this that I can do. I can create a reflection vector, but that isn't quite exactly what I want. So as my camera vector moves, my reflection vector moves opposite that. But what I really want is called a transmission vector. So the purple one down there on the bottom. And that is the inverse of the reflection vector. So if I calculate my reflection vector and then invert it, I can then use that to offset my texture coordinates to get this volumetric effect. All right, remember this green, red, and blue because it's valuable on the next slide. There you go. So here I have my camera vector, and I'm transforming it into tangent space. Here's my normal. And right now, the normal is just 0, 0, 1, because in tangent space, a normal of 0, 0, 1 is just like flat, straight up normal, right? And then here is my reflection vector. So I take the reflection of my normal and my camera vector to get the reflection vector. Now I'm going to take the x and y component, or red and green, of the reflection vector and add that to my texture coordinates. Let's see what we get. All right, this is kind of like mind-blowing, like what's going on here? And it's sort of like I've got my surface and my texture is like infinitely far away behind it, and I'm just kind of rotating the cube like this, right? I can see the thing in it, but it doesn't look like it has any relation to the surface. So we need to alter this a little bit to like offset it less and give me more control. So there are two things that I'm going to do to add control to my effect. All right, so the first thing that I'm going to do is take the z component of my reflection vector and get the absolute value of it. And then I'm going to do 100 divided by that. And this 100 value controls how much offset I'm going to get. And then the other thing that I'm going to do is I'm going to take this, here's a value of 512. And 512 is the actual dimension of my texture in U and V. So this is a 512 by 512 texture. So 1 over 512, and then the z component of my reflection vector. And then I'm going to multiply that by my RNG, and I'm going to multiply the 1 over 512 as well. And what both of these are doing is shrinking the amount of offset that I'm giving it so that when I add it to my texture coordinates, it's not just crazy offset. There's just a little bit, and it's controllable by these values, especially this one here. So the result of that is, ooh, look at that. So it's kind of, it looks like it's relative to the surface, but there's some offset there, and you can see that it's not like flat on the surface. There's actually some depth to it, and it's offsetting. Now this is the heart of the effect, but we can build on it by doing some other things. So the first thing that I'm going to do is I'm going to take a normal map, and instead of my 001 value, I'm going to plug a normal map into here. And this is really subtle, so look really close. I don't know if you can see that, but can you see there's some normal detail on the surface, and then like through the normals, there's like this cool stuff inside the volume. That's pretty neat. There's one more thing that we're going to do, and that is, so right now my surface depth is just kind of this static 100 amount. And what if I take my same noise texture and I multiply that by something and then use that? So instead of a static value, now for every pixel there's a different amount of depth. So what does that look like? Ooh. Yeah. Thank you. I'm glad you like it. Yeah. All right, so there's still a lot of other things. You know, if we actually wanted to imitate what this block of ice was doing, this would be our starting point, and then we'd do all kinds of specular and reflections and stuff. But this is the heart of the effect. So we get this volumetric effect. You know, obviously this object has no volume at all, but we can pretend like it does by doing some math and offsetting our UV coordinates. So once again, a slide full of beautiful HLSL code. And if you like code, you can look at this. If not, don't even worry about it. All right, so we've gone over some really neat examples. We went over volumetrics, cloth, and what was the first one? Cloth was the first one. What was the second one? Ripples. And then ice. So if you're interested in learning to write shaders, what should you do? You're really excited. You saw some neat stuff. You want to go out and do it. Here's some things you can do. Take a look at what other games are doing, because games use shaders to great effect. If you're looking at games, you see something cool, you try to do what they do. Go out and grab a book. There are all kinds of books on this topic. You can do Google and YouTube searches, Mary. And you can download Unreal or use shader effects in Max and Maya to start building shaders like this. And then just like go out and write shaders. Now, last year when I mentioned grabbing a book, somebody asked me, well, what book? And I was like, well, So I made a list of books. So here are some examples of the books that are in my library, especially this first one, the CG tutorial. I learned how to write shader code from this book and all the other books on this list. There may be some newer books out now, but these are the ones that I'm the most familiar with, and so I can definitely recommend them. They're quite valuable. Okay, I hope that you appreciate the art of writing shaders and that you enjoyed seeing a couple of examples, and that now you are filled with the desire to just go out and write them yourself. So thanks a lot. How much time do I have for questions? 20 minutes. All right. So if you have questions, feel free to step up to the mic.
Hi.
Yeah, go ahead.
So I guess I have two questions. The first one is about the ripple. what are the trade-offs between creating a texture that has kind of all those ripples in place as opposed to doing it procedurally, where you just have like the single one and you kind of procedurally place it?
Yeah, great question. So in the animation of the explosion, we only had 36 frames. And that's because we only had space on the texture for 6 frames across by 6 frames down. Mm-hmm. So you're limited to the number of frames you have. So anytime you do this, this Atlas walk technique, you can either have really nice texture resolution per frame, or you can have a lot of frames and have really smooth animation. But you can't really have both. So you have to trade off. You have to decide, like, am I going to get like really high frame rate and really small resolution for each frame, or am I going to have like low frame rate, kind of stuttery, but high resolution? And if you want if you want both, then you have to create this massive texture map, which is kind of going to blow your budget, right? Sure. So if you use math instead, you can have your cake and eat it too, right? You can have really nice resolution and really smooth animation. Yeah.
Okay, great. And then the second question had to do with kind of the other two, with the cloth and the ice shader in terms of lighting. So I know in the first one that it was still kind of using the standard lighting model, and you're kind of faking it. Is there anything else that I guess that you can do to maybe push the faking of the lighting to be able to get that, or like getting light direction information in there maybe, or something like that?
Yeah, so there's a lot of papers on this, like SIGGRAPH papers, where people have measured the BRDF of all kinds of different cloth. Every type of cloth with different thread densities and different warp and weft, they all have different BRDF, which is basically the way that the light is reflected. So if you want to get more technical than this, it's really easy to like jump in and just do something crazy. But the problem with those kinds of things is you're oftentimes limited to a lighting model that is very specific for like just satin, or just cotton. Whereas with this, you can imitate a really wide range of effects. But if you want to get into that, just go and look up some fancier SIGGRAPH papers. This was definitely not designed to be like physically accurate or technical at all. If you wanted to go one step further than what this was doing, you could do this, but use the light vector instead of the camera vector for your Fresnel terms.
Okay, great. Yeah, that answers it. Thanks.
Mm-hmm. Yeah, over here.
Yeah, so to jump off of what you were just saying about modularity that you have in the cloth shader that you just showed, what if you wanted to go wild and say, combine all 3 of those into one, right? That could quickly get messy or hairy. Let's say you did want to do that. What are some of the drawbacks of using that technique of creating one shader that rules them all, so to speak?
I see. So yeah, I mean, it is kind of a strategy of some people to create an Uber shader that can do all kinds of things, and they just turn things on and off. I guess that's what you're referring to. Yeah. There are some good things about that, because it means you're only writing one, and if you update that one, then everything in the game has the new features. And I would say the drawbacks of it are that it can be really performance heavy. But there are definitely some advantages to that technique. I don't think you would want to make one for everything, because there's some really interesting like outlier things that you probably don't want to try to, the bigger you try to make your umbrella, like the farther you're having to stretch it, and it's going to rip when you get to those things that are on the edges. Did that answer your question?
Yeah, it does. Thank you.
All right, thank you. Uh-huh.
Hello.
Hi.
I suppose this might be a very short answer. So you are using divide in a number of different places. Do you ever need to do anything to avoid dividing by 0, like at a very small number or anything like that, or otherwise safeguard against that?
Yeah, so in the spots where I'm using divide in this talk, it's always with a value that I know what it's going to be. In a place where there's a potential of getting 0, you might just add a very, very small number to prevent a divide by 0. We run into that a lot, actually, and usually it's in places that you wouldn't expect. I had an interesting bug at work where something was working fine on a couple of our platforms, but broken on one platform. And I was just like, what's going on? And it was exactly that. Because on some platforms, divide by 0 was treated as a 1, but on other platforms, it was treated as a 0. And so it was just throwing it off. But we were able to find the problem and fix it just by adding a very small number to the value.
Thank you.
Yeah, good point.
Hey, cheers.
Hey.
Yeah, thanks for your talk. I'm sure it will inspire lots of people to kind of get started. Like, I kind of wondered, like, what's the other end of the spectrum? Like, what are the exciting things that you're doing or you see other people doing at the...
You want Shaders 501 now?
Yeah, yeah. Well, like, I know you probably can't go into detail, but, like, you know, just some stuff to look at maybe.
It's actually kind of tricky to pick these examples because I try to pick an example that is something that can be broken down into little steps. Some of these were harder than others to like break down and say, okay, you do this, and then you do this, and then you do this. Yeah, I have to consider all kinds of different techniques. I probably shouldn't get too much into what I'm doing at work, but I am really excited about it. And actually, I'll just say this. I've used all 6 of the techniques that I showed today within the last 2 months or so. So these are like real things that we are really using in production. Yeah.
Okay, cool. Thanks.
Thank you. Yeah.
Hi. Thanks again for your talk. It's more about clarification. In the slide where you show vectors, the green, red, blue, and purple, you said that the purple is the inverse of the reflection, but what makes it different from the green vector?
Okay, so let me go back here. So we're talking about this slide right here. Is that right?
The vectors where you show them like on top of the surface. Yeah, this one.
Okay.
What's the difference between the green and the purple one?
Green and purple. Oh, so green, it just stops, right? It stops at the surface.
Yes.
But the purple one starts at the surface and goes in.
But in terms of vector, isn't it the same vector, I mean, mathematically?
It's the inverse of the reflection. In this example, I made it look like it's the same, but it's really not. I'm sorry.
Yeah, it was like a confusion.
Yeah, no. Good, very good point. Yeah. Yes, thank you.
So I have 2 small questions. Did you start working in code for shaders, or did you start working in nodes, and then did you have trouble transitioning between the 2? And then what kind of shader editing tools does Frostbite or the Old Republic engine have that helps the process?
Okay, it's kind of a long answer. I started learning to write shaders back when CG was a thing, and it's not really now, but back with Pixel Shader 1.0. And back then there were no node editors or anything. It was just like writing code was all there was. So to answer, I'm trying to formulate sort of an answer to all of these at the same time. For Star Wars The Old Republic, our shaders were all in HLSL, so I was writing pure code. And there's some real advantages to writing code versus node-based editors, but there's some advantages to node-based editors as well. In Frostbite, we have something very similar to what I showed today using Unreal Engine. So it's a node-based shader editor. It's also possible to write shaders in code if you want to. I would say an advantage to a node-based editor is that you can be creative and stay in the creative part of your brain without having to worry about, did I put a semicolon on the end of the line? Do I have the right brackets in the right place? Those kind of things pull you out of creative mode and sort of into like the math side of your mind. So when I'm prototyping things, I really like using node-based editors. It's just a lot easier to be creative and not have to worry about getting all your syntax right, that kind of thing.
Okay, thank you.
You're welcome. Any other questions? All right, that's it for me. Thank you very much.